Hello students, welcome back to the today's session of Elements of Civil Engineering. So in the previous video I have already started the analysis of truss, so this problem. So I have already considered the different joint A, B, H, G we have already discussed here. Since the previous video is incomplete, just I am going to complete that the problem in the today's class. So this is what the problem that we have considered, and we have already analyzed this. This is what the given truss is there with the different joints. So just observe, this is the previous video we have already discussed. So how we are going to calculate the support reaction, and we have already considered the joint A and joint H and the corresponding the support reactions and the axial forces we have already calculated. You just see here joint H is also considered and the joint B is also considered. The corresponding internal axial forces we have already calculated. You just see here I have stopped the video at the joint C. So that is lastly I have considered the joint C. You just observe this is what the joint C we are having, right? So this is the joint C. So the remaining joint, so means still we need to determine what is GF and what is FE and what is ED and the remaining member forces. So therefore the remaining joints we need to consider here. So let me continue with the same problem. The different member forces we have already calculated. So now I need to consider the remaining joint, that is next joint I need to consider. Lastly I have considered the joint C and the different member forces we have already calculated. So now I am going to consider the joint G here. So just I will show you with a different slide. You just observe the same thing here. So whatever the joint G is there, so you just observe. So how we are going to draw the free body diagram. So if you are considering, suppose joint G, if you are considering, so this is what the member force GH is there and GB is there and GC, GD and GF. So these are all the forces, and again along with that the 30 kilonewton is also acting. So if you draw the free body diagram, so this is what the free body diagram of joint G. So one more thing you need to observe here, while calculating the member forces by considering the joint C, so we know the value of the different forces, that is GH we have already calculated and GB is also known and GC is also known. So only the unknowns are these two forces, these two member forces we need to find out here. So because the remaining forces we have already have the values by the previous calculation, just I am going to draw the free body diagram here. Just observe, just I am considering the joint. Which joint I am considering? I am going to consider the joint G here. Joint G, I am writing the free body diagram. So free body diagram, just this is what the member forces. One force is load is acting here, so this is the load, and from this another member force is there. So this is also the member force and this is also the member force. So now I am going to write the what are all the member forces along with the whatever the values we have obtained by the previous calculation. So this is what the 30 kilonewton, whatever the 30 kilonewton we are having, and this is nothing but TGF. This is TGF and this is TGD. This is TGD and this is TGC and this is TGB and this is again TGH. So now I am going to write the values of TGH, TGB by the previous calculation. Just I will show the previous calculation. You just observe by considering the different joints. Just observe here what we want. We want the value of TGH right? TGH, we are having the values by the previous calculation, and again we want the value of TCG. You just observe here the TCG value is 0 here, right? TCG value is 0, and TGH, so TGH value or else THG, we are having the value here. Just I will show by considering the joint A. Just observe carefully. By considering the joint A, we are having the value of T, that is joint H, we are having the TGH. You just observe. So this is the value of THG or HG. So just I am writing those values. So whatever the values or the axial forces we have already calculated by the previous equilibrium condition, just I am writing the values here. So THG is nothing but minus 37.5 is there. You just go and observe the value minus 37.5, and TGB is minus 20 is there, and TGC we are having the 0. So there is no need of writing this if it is 0. So we means whatever the member force we are having, this is 0. There is no need of writing this also, and we know that we are already having the inclination, this is 45 degree. So this is what the free body diagram we are having. This is in the form of coplanar concurrent force system. So we can easily apply the equilibrium condition to find out the unknowns. So firstly I am going to consider the equilibrium condition, summation of vertical force is equal to 0, summation of vertical force. So just I am writing the different vertical forces. 30 kilonewton is there which is moving downward, that is why I am writing minus 30, right. So then we are having minus this force I need to write, because this is horizontal we do not consider this one. So because we need to resolve the two inclined forces, this is what the resolution we are having, one horizontal and vertical. So for this also we are having the resolution, one horizontal as well as one vertical force is there. So the vertical component, since I have considered the 45 degree with respect to x axis, the vertical component will become sine. So therefore TGB, I am writing the TGB, vertical component will become sine 45 degree, sine 45 degree. So similarly, since it is downward direction, therefore it is minus. Again minus this force I need to consider, again it is making an angle 45 with respect to x axis, y component is sine, just I am writing TGD sine 45, this is equal to 0. So now I am substituting the value minus 30 minus TGB. So is nothing but TGB, already we are having the negative value minus 20, you need to substitute, that is sine 45 is equal, and as it is minus TGD sine 45 is equal to 0, sine 45 is equal to 0. So you just observe with this, in the entire equation only the unknown is TGD. So by simplifying we are getting the value of TGD as minus 17.67 kilonewton, that is in the compression. So that is what, so since we are getting the negative value, so therefore this is in the compression. Clear? So now this is over. So that is I have considered the summation of vertical force is equal to 0. Next I am going to consider the another equilibrium condition, summation of horizontal force is equal to 0. So what are the horizontal forces? TGH is there, just, and it is in the negative direction, this is negative direction, therefore minus TGH, here minus TGH, and again TGF is in the positive direction, plus TGF, and again this is in the positive direction, positive TGD cos 45, because it is making an angle with respect to x axis. Similarly this force, that is TGB, that is in the negative direction, minus TGB, again it is cos 45 is equal to 0. So now we need to substitute the values. TGH value we are having, that is 37.5 is there, that is minus of minus 37.5 you need to substitute, plus TGF as it is, then TGD cos 45. TGD value we are already having minus, therefore minus 17.67 cos 45 we need to substitute, and TGB, again TGB minus 20 is there, minus of minus 20, that is cos 45 is equal to 0. You just observe here, in the entire equation TGF is unknown, that is TGF is only the unknown. By simplifying this, you will get the value of TGF as 42.68 kilonewton. Since it is also negative, the member is in compression. So as I told you, you need to assume at the beginning, you need to assume all the forces are in the tension. So means they are moving away from the joint. But suppose if you are getting the value negative, it indicates what? The member is in compression. That is what the meaning. So in order to avoid the confusions, I am making only the one assumption, all the forces are tensile here. So now by applying this member forces, now we have the value of TGD and TGF. So remaining in the entire truss, the remaining is TEF as well as TED are the unknown. Either you can consider the joint D or you can consider the joint E. So you can easily find out the remaining unknowns, right? So now I am going to consider the next joint. You just observe this. By observing the point D, again we are having CD value is known, DG is known, unknowns are these two. So therefore easily I can consider the joint D and I can apply the equilibrium condition now. So now I am going to consider joint D. The same figure is there, just observe the joint D. I am going to consider, just I am writing the free body diagram. So this is one of the member force which is acting axial force. This is DGD and DF and DE. So this is what the free body diagram. Just I am writing the free body diagram here. Suppose if you are considering the joint D, which joint? That is joint D. I am considering joint D. Just I am writing the free body diagram here. So this is TCD, right, and this is TDG and TDF is there and TDE is there. So just I will write the values. So because whatever the values we are having already by the previous equilibrium condition, so I need to write this. This is what? TDE. Just observe the figure, you will get an idea. So this is TDF and this is TDG and this is TDC. So just I will make an extend for this. This is what 45 degree we are having. So this is in the coplanar concurrent force system. I will write the what are all the values we are having. TCD we are having, that is 55.1 is there, and TDG. So TDG value also we are having, that is minus 17.67. By the previous calculations we are having these values. Just if you want to see, means I will show you. This is what the previous calculations. By this we are having the value of, that is TCD as well as TDG. Just TCD is there, just observe here TCD value, this one, right. So similarly we are having TDG also, the same value I have substituted here. We need to substitute whatever the member forces we have already calculated. So now we need to apply the equilibrium condition. So summation of horizontal force is equal to 0. I am applying the equilibrium condition. Summation of horizontal force is equal to 0. So TCD, so just I will write directly, minus 55.1 is nothing but what? TCD value. So again you just observe the figure, we are having only one inclined, this is two inclined forces. We need to resolve these inclined forces. We know that how to resolve it, and I am considering the inclination with respect to x axis. X component is cos and y component is sin here. Just I am writing that is minus 55.1. Then again this force TDE I am writing, so is nothing but what? It is in the positive direction. So therefore plus TDE, and since that is TDE I am considering TDE, it is making an angle 45 with respect to x axis, therefore cos 45, and again another force is there, this one, and it is in the negative direction, minus TDG, again this is cos 45 is equal to 0, right. So but we are having the TDG value, just we want to substitute minus 55.1 plus TDE as it is cos 45, right. So minus TDG value we are already having, minus of minus 17.67 into cos 45, we need to substitute in the entire equation. TDE is unknown now, TDE value we are getting, that is what? 60.02, that is positive, therefore it is in the tension. So you just do the calculation, and after that you just check it whether we are getting the same value or not, right. So now the second equilibrium condition, summation of vertical force is equal to 0. Summation of vertical force. So again vertical force means TDF is there, moving upward, this one positive, right, and the vertical components, that is also positive, plus TDE sin 45 now, clear, and plus TDG again sin 45, this is equal to 0, right. So in the entire equation TDF is unknown, TDE this is we have already calculated here. Now TDF is unknown, plus TDE value we are already having 60.2, that is sin 45, plus TDG sin 45 is equal to 0. You just observe this entire equation. Again TDF is the unknown. By simplifying that, we are getting the value of TDF as a 30 kilonewton, that is negative, that is in the compression, right. So this is in the compression, 30 kilonewton. So you just take it the value of 30 minus 30. So now just observe the figure, and let me think, we are consider the different member forces, or all the members we are having the values except the TFE. So lastly we need to find out only this member. So this is, now we have already calculated this, we have already calculated, and previous also we have already calculated. Only the unknown is here what? FE is only unknown, right. So either you can consider the joint F, or else you can consider the joint E to determine the unknown member force which is acting. So now I am going to consider the joint F here. Just I am going to consider the joint F. Just I am writing here which joint I am considering. I am considering the joint F now. Just I am writing here. Okay, this is the joint F. So if I draw the free body diagram of joint F, how the free body diagram should be, this is what, wait for a while, okay. So okay, if I draw the free body diagram of joint, so how the free body diagram, so that is you just observe, so this is one of the force which is acting, so this is one of the force, this is, and 30 kilonewton is acting here. So just I am writing the free body diagram, just wait, I will write here. Okay. Okay. Okay, just F I am considering, just I am writing the free body diagram. Okay, this is what the free body diagram. So if I write, this is 30 kilonewton which is acting, and again another member force, that is TFD, right, and this is TEF, and again this is TEG. So this is what the this is TFG, right. So because I have considered the joint F here. So this is what the free body diagram of joint F. So suppose I want to apply the equilibrium condition for this, and we are having already Fg value, that is by the previous calculation, just go and check it, Fg value is there, minus 42.68 is there, and Fd again minus 30 is there. Fd is nothing but df, whatever the value we have calculated right now. So now only the unknown is Tfe now, right. So therefore I need to consider summation of horizontal forces enough, because Tfe is only the unknown now. So therefore this is in the positive direction, Tfe minus Tfg is equal to 0. So Tfe is equal to minus of minus 42.68. So since it is positive, so if you take it on the right hand side, so then what happens, this value will become negative. That is what, that is Tef is becomes minus 42.68, since it is negative, that is in the compression. So this is how we are going to determine the different member forces which is acting on the given truss. So now you can observe the entire truss, you just observe. So we have considered the different joint, right. Just I will show the different joints here, joint F, joint D, right. So again joint G I have considered. In the previous video we have already discussed about the remaining joints. You just observe here, joint A is there, joint H is there, B is there, so and C is there. So like that you need to consider the different joints and you need to apply the equilibrium condition. So what is important here, the considering the joint is important here. So means how we are going to consider the joint. The joint should be considered such a way that there should be a maximum of 2 unknowns. So if you are considering any joint first, it should have only 2 unknowns. So then only you can calculate using summation of horizontal force is equal to 0, summation of vertical force is equal to 0. So therefore the joint should be chosen such a way that there should be a maximum of 2 unknown, minimum 1 or 2, maximum 2 unknowns should be there. So means what is the meaning, we cannot consider the G joint first, we cannot consider D first. So we should consider the joint such a way that there should be having the minimum unknown. So therefore I have started the joint from the A. So this is what the complete explanation how we are going to find out the axial forces, member forces which is acting on the given truss. So now what we need to do, we need to make the list of all the forces, that is axial forces or the member forces which is acting on a truss, and we need to write the nature of the forces. So I have listed here whatever the axial forces we have calculated, the same forces I have listed, and we need to write the what are all the magnitude and the direction, whether it is in the tension, compression or what is the direction of that member, the particularly that direction you need to make the list of this all the member forces, or else you can make the simplified diagram also. So you can write the member forces above that member only by showing the different the notation. That is we know that that is AB is how much it is 53.03. I can write here tension, therefore positive, and AH is there that is compression, therefore minus 37.5, right. So then is nothing but BH is there minus 20, again compression I am writing, therefore it is minus 20 here. So similarly, so this is minus 37.5, and that is BG. BG is nothing but we are having, that is BG is nothing but 24.74 is nothing but 25, that is in the compression, therefore I will write the value it as minus 25, and GC we are having the 0, that is the 0 member force, and this is 42.68, right, 42.68, that is FG. Just compare the values of what I am writing with the member forces. And again GD is nothing but so here we are having, that is GD we are having, that is 17.67, that is compression, that is 7.67, and again CD is 55.1, and again BC is also 55.1, and this is minus 30 FD. Just observe that is FD is equal to 30, compression just therefore I am writing the minus, and this is 60.2, and the remaining minus FA lastly, that is 42.68. So like that you need to show the member forces which is acting on the given truss, and along with that you should make the tabular column. So this is what the complete analysis of truss by the method of joint. So you may get in the examination up to for the 15 marks question, it is entirely. So very simple, but it is lengthy is there. You need to consider each joint and you need to apply the equilibrium condition. First you need to determine the support reaction, and by choosing the joint such a way that there should be a maximum of 2 unknowns. The rest of the things are similar, only the concurrent coplanar concurrent force systems will exist. So after that you need to apply the equilibrium condition and finding out the unknowns. So this is what the complete video which is gives you the analysis of truss by the method of joints. So let us continue the remaining things in the next session. So this is what the half of the video we are having. The previous version, that is the beginning of this video, I have made the different video since it is incomplete, therefore I am completing the same problem in this video. So let us continue the remaining problems in the next upcoming videos. Thank you.